For today's opener, we need to look at Bugs Bunny. He's 42 meters below ground, digging his way towards Albuquerque, and he realized he wanted to be above ground. He wanted the sunshine or some air, I don't know what. So he turned and went on a diagonal for 100 meters until he was above ground. Well, that's interesting, but what does that have to do with trigonometry? Well, if we have a picture for this, and I want to know what's the angle of elevation in degrees of Bugs Bunny's climb, angle of elevation, that means this angle right here. So notice we have a triangle. Here's Bugs Bunny to start with. He starts digging on a diagonal of 100 meters, put meters there. He started 42 meters below ground. So we actually have here a right triangle. Oh, that's a terrible bottom one. Let's draw that again. There we go. So I'm asking to find this angle. Let's call this angle theta. Instead of using A or B or C, theta is a Greek letter. Pronounce that theta. Okay, so just like we've done in all our other problems, now I'm just giving you a triangle with two sides and ask you to find the angle. So how do we do that? Well, the first thing we do is let's label our sides. So the one across from the right angle is the hypotenuse. And the one that's across from the angle we're looking at, that's the opposite leg. And that means that the other one is an adjacent leg. But since we don't have a length for that, I'm not even going to write that. So what we're looking at is the opposite leg and the hypotenuse. So which trig function do we use? Well, if you remember, so, ka, toa tells us what we use. So we're looking for what uses the opposite leg and the hypotenuse. Opposite leg, hypotenuse. That would be S, the sine function. So we're going to say the sine of our angle, which we're calling theta, is equal to the opposite leg, which was 42 meters, over the hypotenuse, which was 100 meters. And now we just need to solve for theta. So how did we figure out to solve an equation that looked like this, where the variable we're looking for is inside the sine function, or cosine or tangent for that matter? Well, we learned about an inverse function that undoes the sine. So the angle theta is going to be the inverse sine function of our fraction on the other side. And we're going to need a calculator to come up with an approximation for this. So I'm going to grab my calculator, make sure I'm in degree mode, and we're rounding to the nearest tenth, keep that in mind, and I need to do the inverse sine of 42 over 100. So I grab my calculator, make sure I'm in degree mode, check. So second sine gives me the inverse sine, the sine with that little negative 1 there. The inverse sine of 42 divided by 100. And there's the angle of elevation, 24.83. And so it said round to the nearest tenth, so we're going to chop it off after the 8. The first number after is less than 5, so we're not going to round the 8 up to 9. It's going to say 8. So 24.8 degrees. We read the problem, double check what they wanted. Angle of elevation, nearest tenth. Check, check, and that's it. So for the assignment today, we're just going to be doing a few word problems. So let's talk about that. Let's actually look at some of those. The first thing you need to do when you're solving word problems using trig is make sure you draw a picture. Now, a lot of times the picture will be drawn for you, but if it's not, you need to draw the picture. Next, you want to label all the parts that are given to you, all the information from the problem, mark that in your picture. Then you decide from what's given, are we going to use sine or cosine or tangent, and we write an equation, and then we solve it. All right, so if you look at the first problem, pretty straightforward. You've got your triangle there, it's labeled, you need to solve for x. So that's kind of like the opener. Second problem, same thing. This is a 90-degree angle here, so we have a right triangle. we know an angle, we know one of the sides, we want to find the other side. So you can just call that x and set up your equation with that. For problem number 3, you need to draw your picture for this. So I'm not going to draw the picture, but you can visualize a ladder leaning against a house. That's going to make a right triangle. And it says the ladder leaning against the house makes an angle of 30 degrees with the ground. So that's kind of like where the 60 degrees is from the picture above. And then make your right triangle, plug in the numbers you know, and solve it. Then on number 4, we get a little tougher. And so what you need to do is we have you're looking at the top of a tower. And so we can make a right triangle from that. And so that's one triangle. And in that triangle, we know this is 42 degrees. And we know this is 780 feet. So you can actually figure out this entire distance here. Now your friend is standing a lot closer to the tower, and we can make a right triangle for your friend. And you'll have your right angle here. This is still 780 feet. That's the height of the building. But now the angle is 71 degrees. And so you can figure out this distance here. Why? So back in the original picture, this will be y, and that will be x, and what they're looking for is the distance between you and your friend. So obviously if you know that red distance, you can subtract the green distance, and that'll give you what they're looking for. So that's the approach on that one. And then the last homework problem, there's only 5, so it's not too difficult. You'll notice that we don't have a right triangle here, and they want you to find the distance from B to C. So they want that length. So what you're going to need to do is make a right triangle. They give you a hint. It says add the altitude from vertex B. So what you're going to do is from B, we're going to split this 110 degree angle, and we're going to make 2 smaller right triangles out of that. Now, if you know that angle A is 42, and this is 90, you can figure out what this angle is here. And then if the whole thing was 110, whatever you figured out for this angle, you can subtract from 110 to get this angle. So now in both of these triangles, you know angles, you have 90 degrees. So with this side, you should be able to find this piece of that smaller right triangle. And then with this triangle, now that you have this figured out, and you'll have this angle here, you should be able to figure out BC. So, I'll let you think about it. I'm not going to step you through it, but that'll take a little bit more work than the other ones. All right, good luck.